We're all familiar with sci-fi movies and their focus on galactic space expeditions, such as Interstellar, Star Trek, and Lost in Space. One thing these movies all have in common is the appearance of a black hole. After watching such movies, it makes you sit back and wonder if the existence of a black hole is really just plain make-believe, or if it's actually not too far from reality. Surprisingly enough, black holes are a very real concept, and one has just been photographed for the first time in history. But first, what is a black hole? Now, contrary to a simple black dot in space, a black hole is a region of spacetime where gravity is so strong that nothing, no particles, or even electromagnetic radiation, such as light, can escape from it. The theory of general relativity predicts that a sufficiently compact mass can deform spacetime to form a black hole. Albert Einstein first predicted the existence of black holes in 1916 with his general theory of relativity. The term black hole was coined many years later in 1967 by no other than American astronomer John Wheeler. After decades of black holes being known only as theoretical objects, the first physical black hole ever discovered was spotted in 1971. So far, astronomers have identified three types of black holes: stellar black holes, supermassive black holes, and intermediate black holes. A stellar black hole is a black hole formed by gravitational collapse of a star. They have masses ranging from about 5 to several tenths of solar masses. The process is observed as a hypernova explosion or as a gamma ray burst. These black holes are also referred to as a collapsar. A supermassive black hole is the largest type of a black hole, with a mass an order of millions to billions of times as the mass of the Sun. Black holes are a class of astronomical objects that have undergone gravitational collapse, leaving behind regions of space from which nothing can escape, not even light. Finally, there are intermediate black holes, which are basically black holes in between stellar and supermassive. At first, scientists believed that there was no such thing until a discovery of one was made in 2014 in our galaxy. Although the existence of a black hole was already determined by John Mitchell, and later coined and confirmed by Albert Einstein and John Wheeler, a picture was never taken. So in April 2017, astronomers decided to go on a 5-day journey to take the first ever picture of a black hole. This is Albert Einstein and this is John Mitchell. In our case, we're dealing with a supermassive black hole called Bowehi, which is 6.5 billion times as massive as our Sun. The supermassive black hole and its shadow at the center of the galaxy known as M87 were photographed using a technique that involved 8 telescopes. The picture is by no means HD, but the simple fact that we were able to take a picture of nothing, it's out of this world. And this right here would be the official picture of Bowehi. This is Shepard Dolman, head director of the Event Horizon Telescope. He was tasked with giving us the first picture of a black hole. He explained that his research focuses on studying supermassive black holes with sufficient resolution to directly observe the event horizon. In order to do this, his chosen group assembles a global network telescopes that observes wavelengths to create Earth-sized virtual telescopes using the technique of very long baseline interferometry. Now, in order to understand how this is done, we must understand what the event horizon in a black hole is. The event horizon of a black hole is linked to the object's escape velocity, the speed that one would need to exceed to escape the black hole's gravitational pull. The closer someone came to the black hole, the greater the speed they would need to escape that massive gravity. The event horizon is the threshold around the black hole where the escape velocity surpasses the speed of light. Avi Loeb, chair of astronomy at Harvard, said that the event horizon is the ultimate prison wall. One can get in, but never get out. Now that we know that, we can go back to the method. See how this is done is by a technique called very long baseline telemetry, which synchronizes and links radio dishes around the world by combining this network to form one huge virtual Earth-sized telescope. The EHT is able to resolve objects as small as 20 microarcseconds on the sky, which is the equivalent of someone in Earth identifying an orange on the moon. Data recorded at the EHT sites around the world is transported to a special supercomputers at MPI and at MIT's Haystack Observatory, where they are combined. The combined data set is then carefully calibrated and analyzed by a team of experts, which then enables EHT scientists to produce images with the finest detail possible from the surface of the Earth. Now that's a long process, and it's not as simple as the picture makes it look. The 8 telescopes were used to create a telescope as big as the Earth in order to see and take an image of the supermassive black hole. Each telescope collects and records radio waves coming from within the black hole. The data are then combined to create the image of the event horizon. The way this worked was by synchronizing the telescope to ensure stability. The EHT uses atomic clocks that lose only 1 second every 100 million years. The amount of data recorded during observation is so large that it could never be transferred over the internet. Instead, the recordings are stored on hard disk and shipped to a central facility for processing. And this will be all the telescopes that they use. Once the data reaches the supercomputer, all the data is combined, staggering during playback to account for the time difference between waves getting to each telescope. This data can then be used to make images with extreme magnifying power. And this would be what a supercomputer looks like, the one that was used. The result was the famous image that shocked the world in 2019, and the one where we could see everywhere today. This would be Owehi, the image taken by the EHT. And it looks like this guy was right after all.